Hi there. Uh, Today we want to look at integer representation. We want to look at how integers are represented in a computer system, and our first interest is to look at the different number systems which are there. And here we are talking about the decimal number system, which is base 10. We are looking at the binary number system, or the base 2 number system, and we shall also look at the base 5 and base 8 number systems, and we shall also see how to do conversions among these number systems. It will be also of interest to see how additions are done. So let us see what we have in this lesson. Now, we use numbers for counting, okay, and the most common number system is the decimal number system. When we say decimal, we mean numbers which are in base 10, and these are numbers you and I are acquainted with because we use them in our everyday counting: 1, 2, 3, 4, 5, 6, and when we reach 9, we start recombining these 10 digits. It will be 10. 10 is a 1 and a 0. 11 is a 1 and a 1, and so on and so forth. But there are actually other types of number system, and these are the binary number system, which is in base 2. There's the quinary number system, which is base 5. There's the octal number system, which is base 8. And we have the hexadecimal number system, which is base 16. For purposes of this lesson, we shall just look at the decimal number system, the binary, quinary, and the octal number system. Now, what is the decimal number system? The decimal number system consists of these 10 digits from 0 to 9. If you count them, they actually turn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, digits in a base 10 number can be expressed with the number 10 as the base to the power of the value of the place of the digit in the number. Now, let me explain something here. Let me pick a pen. What do we mean by base? If I wrote 2 to the power 5, this number here is what you call the base. Okay? Now, what we are saying is numbers which are written in base 10, each of the digits in that number can be expressed with bases which are with bases which are the digit 10. So, for example, if we have 856, what we have is this. Where's my pen? Okay, so what we have is this: 8, 5, 6. So this number is in base 10, and what this means is each of these digits can be expressed with a base of 10. So, for example, this occupies the ones position, and we can express it as 6 times 10 to the power 0. Okay, what you have here are ones, tens, hundreds. So then 5 can also be expressed with 10 as a base, so what we'll have is 5 times 10 to the power 1, and then 8 can be expressed. 8 is in the position of hundreds: ones, tens, hundreds. So what we have is 8 times 10 to the power 2. Now, what you should notice here is 10 to the power 2 is 10 times 10, which is 100. So in other words, this is 8 times 100, which is the same as 800, right? Likewise, 10 to the power 1 is 10. So this is 5 times 10, which is 50. 6 times 10 to the power 0. Any number to the power 0 is 1. So this is 6 times 1, because 10 to the power 0 is 1. So what you have is 6 times 1, which is 6. So when you look at these figures, 800, 50, and 6, when you add them, what do you get? When you add all these digits, 800 plus 50 is 850, plus 6, it will be 856. It will give you this value we have here. Okay. Now, we can change base 10 numbers to other number systems. So, for example, we can convert a number to base 2 by repeatedly dividing by 2. So let's see what that gives us. So for example, if we want to change 20 to base 2, what do we do? What we shall be doing is we shall start dividing with 20 itself, 20 divided by 2, and the result you get is a 10. 20 divided by 2 is 10. What remainder does it give you? 0. So next we write this 10 here. The result of this division, we divide it by 2. 10 divided by 2 gives you 5. It leaves a remainder 0. Next, what do we divide? It is this one here, the quotient. 5 divided by 2, it gives you 2. What remainder? It's 1. So 5 divided by 2 is 2, and it leaves out a 1. What about 2? Because we are now here. So we are dividing 2 divided by 2 equals 1, remainder 0. So 1 divided by 2. How many times does 2 go into 1? 0. What does it leave? It leaves a 1. Okay. So now these digits here, we have a 0, 0, 1, 0, 1. Now when we read these digits, starting from the bottom going up, what we have is 1, 0, 1, 0, 0. This. So what this means is the number 20 in base 2 is 1, 0, 1, 0, 0. That is how it is done. So how about converting base 10 to base 5? Again, whatever number which is in base 10 which you want to convert to base 5, you need to keep dividing that number by 5, and the result you get, you simply write it in reverse. You take the numbers you write in reverse are the remainders. So for example, if we want to convert 20 to base 5, it will be 20 divided by 5. The answer is 4. What remainder is there? It's 0. So likewise, 4 divided by 5 equals 0. Remainder 4. Okay, so 5 can't go into 4. So what do we remain with? The 4 itself here. All right, so that means 20 when converted to base 5 is, again you write from the bottom here going up, and that gives you 40 in base 5. Okay. How about converting base 10 numbers to base 8? Again, you divide whatever number you want to convert to base 8, you repeatedly divide it by 8 until you can't divide anymore. So 20 divided by 8 equals 2, and it leaves a remainder of 4. Next, we pick this number 2 here. 2 divided by 8, it is 0. It leaves you the remainder 2. So what we have is 4 and 2, writing it starting from the bottom, what we have is 2, 4. So 20 in base 8 is 2, 4. 2, 4, all right?